Hello everyone, this is Mr. Sullivan again. I just wanted to go through a couple of the problems on the homework for multiplication and division of rational expressions. Hopefully you're doing well with it, but in case you had any questions. So I'm going to start with number one. Again, we said the idea is to factor everything that we can. So I'm going to go ahead and factor the numerator. Looks like I have difference of squares, x squared minus y squared. So I'll factor that as x plus y times x minus y. Now the denominators are already in a factored form. What I'm going to do is I like, again, to see the factors separated. So I'm going to separate the x minus y squared as x minus y times x minus y. And then that's times the right-hand fraction. Looks like everything's factored, ready to go. Now before I simplify or cancel, I want to make sure I state the restrictions. And this is where it's a little bit complicated here. We said the idea when we're stating restrictions is to set any factors in the denominator that contain variables equal to 0 and solve for x, or solve for a variable. So I'm going to go ahead and do that. I'm going to say x minus y equals 0 and x plus y equals 0. Now if I solve for x here, what I'll notice is I find that x cannot equal y. Okay, and for the second equation, x cannot equal negative y. And that's perfectly satisfactory in terms of stating the restrictions. It describes what values the variables cannot take on, so I'm going to go ahead and use these as my restrictions. Now I'm ready to go ahead and simplify, again, vertically or diagonally, so the x minus y can cancel with the x minus y, the x plus y can cancel with the x plus y, and my final simplified form would be 1 over x minus y. Okay, let's take a look at a problem like number 4 next. Okay, let me just slide up. So again, factoring, looks like I have a GCF in the numerator of the left-hand fraction. I could pull out a 2x, and I'm left with x minus 8. The denominator, sum product factoring, x minus 8 times x minus 1. Again, I'm leaving this as division for the time being. 2x over 5 times x minus 1. Now I'm ready to state my restrictions. Each factor in the denominator set equal to 0, so I'll find that x cannot take on a value of 8 and x cannot take on a value of 1. Again, I don't need to set 5 equal to 0, only factors that have a variable included. I'm now ready to go ahead and change this into a multiplication problem by multiplying by the reciprocal or keep change flip. So 2x times x minus 8, I leave the left-hand fraction alone, over x minus 8 times x minus 1. And I can now multiply this by 5 times x minus 1 over 2x. But again, we note that we've introduced a new factor into the denominator, the 2x, and so I have to set that equal to 0 and solve. And when I do that, I'll find that x equals 0. So an additional restriction to make sure I consider. Okay, let's go ahead and simplify. X minus 8 and x minus 8, x minus 1, x minus 1, 2x and 2x. So it looks like everything cancels out except for the 5. So final answer, this simplifies to be 5 with the understanding that x cannot take on a value of 8, 1, or 0. Okay, I'm going to jump down to the last two because that's where the factoring gets a little more difficult. Okay, so just make sure that you guys are up on your factoring. So left-hand numerator, I'm going to, again, I like to use guess and check. So I'm going to say that because 3x squared, the 3 is prime, I know that this, when I factor, I'm going to have a 3x and an x, and 5 is also prime, so it's a 5 and a 1, and I need to decide where to put those. Again, I'll go ahead and experiment a little bit. I'll put the 5 on the left and the 1 on the right. I know I want to multiply to equal a negative 5 and add to equal a negative 14. I know I need one of the factors to be positive, one to be negative. So I'll play around a little bit. I'll put a plus 5 and a minus 1. But if I FOIL now, when I do the outside and inside terms, I get a minus 3x and a plus 5x. That'll add to equal a positive 2x, so that doesn't help. So maybe I'll go ahead and erase and try my new signs. I could switch the signs and I can make it a negative 5 and a positive 1, but that just gives me negative 2x when I go ahead. So it looks like I need to switch the place of the 5 and the 1. So again, I'll go ahead and replace those. Okay, a little trial and error here. And so I could put the 5 over on this side, the 1 over on that side. Now we see some nice things happen, right? If I make this a negative 5 and a positive 1, when I do the outside and inside terms, I get a negative 15x and a positive 1x, and those add to equal negative 14x. So there's my factors, okay? And in the denominator, it's going to factor. It looks like I'm going to have an x plus 6 and an x minus 2. And then I can go and multiply. I can pull out a 10 times x plus 6. And I can pull out a 4. And I'm going to be left with x squared minus 25 when I pull the 4 out. So I'm going to go ahead and factor that as difference of two squares. So x plus 5 and x minus 5. Okay, so now this is multiplication. I can go ahead and state my restrictions. Each factor in the denominator equal to 0, and so I'll find that x cannot take on a value of negative 6, positive 2, and plus or minus 5. Okay, so those are my restrictions. Let's simplify what we can. X plus 6 and an x plus 6, an x minus 5 and an x minus 5. 2 goes into 4 twice. 2 goes into 10 5 times. So I'm left with 5 times 3x plus 1 over 2 times x minus 2 times x plus 5. Okay, that looks like my simplified form. Let's close with parentheses there. Okay, no need to multiply those through. And along with my restrictions, that's my final answer. Okay, last one, number 10. When I go to factor, it looks like I've got some, the left-hand numerator, if you remember back from our factoring days, this is a tie between difference of squares and difference of cubes. Essentially, x to the 6 minus 1 could factor either way, but whenever something can factor as difference of squares or difference of cubes, we have to factor it as difference of squares. So I'm going to factor this as difference of squares first, so that becomes x to the 3rd plus 1 times x to the 3rd minus 1. Okay, this is over. Pull out a 5, I have x to the 3rd plus 1. Okay, this is divided by, now x to the 9th minus 1, that is only difference of cubes. So I'm going to factor this as x to the 3rd minus 1 times x to the 6th plus x to the 3rd plus 1. Okay, and this is all over 5. All right. Now, what we notice here is that we can factor these guys further, but you also may notice that you can do some canceling now. So what do? Well, really could go either way. The safest bet is always to factor everything as far as we can. So I'm going to go ahead and do that. But if you were to, at this point, take your denominator, the factors from your denominator, set them equal to 0 and solve, you would find that x to the 3rd equals negative 1. And then when we solve that, we would get x equals negative 1. So this is a restricted value, okay? And then you'd be eligible to cancel there. After you flip, same thing with the x to the 3rd minus 1. You could set that equal to 0 and solve, and go ahead and cancel there. But to be on the safe side, I always like to factor everything out. So left-hand numerator, I've got two sets of of cubes problems. One sum of cubes and one difference of cubes. So I'll factor sum of cubes first. X plus 1 times x squared minus x plus 1. And the x to the 3rd minus 1 will factor as x minus 1 times x squared plus x plus 1. And that will be over 5 times x plus 1 times x squared minus x plus 1. This will be, now I can go ahead and flip at this point, okay, because I've already identified the restrictions from the denominator. The 5 is not going to yield any restrictions. I found that x cannot take on negative 1 from this factor. The trinomial here, if I set that equal to 0 and try to solve, I'll yield only imaginary values, and so those don't need to be included in my restrictions. It's only real numbers that need to be included in the restrictions. So I'm going to go ahead and flip here, and x to the 3rd minus 1 can factor as x minus 1 times x squared plus x plus 1. And of course I ran out of room. Let me slide over a little bit. And that will be multiplied by the x to the 6th plus x to the third plus 1. Okay, so now I've got everything completely factored. I cannot factor anything any further, so let's go ahead and simplify. There and there, there and there, diagonally, x minus 1, x squared plus x plus 1, and then finally the 5 and the 5, and so it looks like I'm left with 1 over x to the 6th plus x to the 3rd plus 1. Now, you guys should be yelling at me right now, okay? When I flipped, I forgot to consider this restriction, and so we have an additional restriction that says x cannot take on a value of positive 1. Okay, so make sure we always consider whenever we have a division problem and we flip, we have to consider all restrictions. So therefore, final answer 1 over x to the 6th plus x to the 3rd plus 1, with the understanding that x cannot take on a value of positive or negative 1. Okay? Your teachers will be available to answer any questions. You can certainly make an appointment during office hours or during some of the opportunities where you guys have to interact with them in some way on a live basis. Okay, good luck, guys.